about you. Yeah,
Sure, why not? On Discord, it's not. There's not an echo, so.
There it is.
All right, so we're starting section 5.4 today. This is solving exponential and logarithmic
No.
equations. So can somebody think back to what the one-to-one property is? Or one of the ways to write the one-to-one property?
Log B
Bless you.
of bx.
One-to-one is not b to the x here.
No, wait, I have it written down.
No, think about it.
No, I'm coming up.
Think about it.
Never mind.
What's the one-to-one part, Max?
Like if you have the same base of two logs, then like their
Log B of x.
main thing will be equal to each other.
Ah.
What am I missing? What do I fill in?
Because of x and then of
Exponents.
y, then x equals y.
So this is true. This is true. What?
If and only if.
If and only if
X equals y.
equals y, right? That's the log version of the one-to-one property. You remember what the exponential version is?
It was
AX.
Ax
Or no,
A
A
to
to
the
the
X.
X.
a to the x
Equals a to the y. Or b to
B
the
to
y.
the Y.
Or-
No,
A to the.
Oh yeah, a to
A
the
to the
y.
y.
A
has to have the same base.
Yeah,
Yeah,
my
a to the y.
apologies.
They have to have the same base. A to the y.
So
is
the log has the same base,
So
and
x.
the,
So a to the x equals a to the y, and that's if and only if x equals y.
x equals
That's
y.
what one property is.
Right, that's the one-to-one property. And then, do you remember what inverse properties are?
Yes, sir.
It's an inverse property
Oh,
Inverse.
like the inverse properties of logarithm stuff.
of logs. Yep. There's two ways of writing it. What's the stuff that we've been crossing out?
Oh,
When the base
Base is
and the
equivalent
main
to-
part like have a factor in common.
No, not factoring. No, it's when we're crossing out like logs and exponents and stuff.
Oh, when you bring it to the exponential.
So it's like log base 10 of 10. You just make it 1.
So that's true. Log base 10 of 10 equals 1. But the inverse property, why is this 1, by the way? Where's the 1 over here?
'Cause it's 10
Where's-
to the power of 1.
10 to the power of 1. So this part cancels. So instead of saying a specific base here and a base here and a specific exponent, how can I write that in general?
What?
Using like b for my base, let's say.
Oh, okay, so log B.
Log b of,
Oh wait, no, is it the one where the log is in the exponent or no? What's
there's two ways of writing it. So we'll do it both ways.
log B of base log base B of B, right? So the x equals x.
Right. This cancels, right? So this is in general. So Max, from your example, b was 10 and x was 1. So this is true for a specific example, but here's my property. Here's my general way of writing that. So what's the other way of writing it? What else cancels?
The b's.
So this is log base b of b to the x. How can I do it the other order?
B to the power
b to the log b to the log base b of x equals x. That's my inverse property. my two ways of writing inverse property and my two ways of writing one-to-one property. These are going to be massively useful when it comes to solving exponential and logarithmic equations. So I'm going to make a little table here. This is not anything that you have to memorize or write down. I'm just doing it in this way because it makes it really convenient to show a bunch of stuff at the same time.
Mr. Shadle, for the one-to-one property, you put those equals mass x.
One-to-one.
What do you mean?
Yeah, on the top one you did.
X and X.
Oh, yeah.
is
Thank you.
Y.
Right. So I need a y here.
Oh, that makes a lot more sense.
Oh, did you have it the old way? Oh yeah, b to the log base b of x equals log base b of x. That's always true.
If no, it's
If and only if x equals x.
If and only if x equals y.
I had an x here by mistake.
Yeah,
Yeah,
I
you
know.
would.
But it only works if x is equal.
I don't think so.
That's what you wrote.
Right. Solution, and then the
So
property.
you don't have to write this part?
He says it's
So if I'm giving you a table, sometimes it's like rules or things that you have to know. I would write this stuff down, but I'm just giving you a bunch of examples. So here's my original equation.
Do we have to copy all of these?
Yes, write down all these examples because you're gonna have to do a bunch of these for homework, and you're gonna want to have examples to look back on.
And this is for the next section.
This is 5.4.
5.4a.
I have notes organizers here if you want the notes.
Yeah, we'll do that in too.
Yeah.
Just like that from all.
Okay, bye. Probably be back. Or at the end of each one.
No.
Or you'll have the morning at home. Either way is good.
That's a lot of problems.
So, looking at this first one, for example 1, how can we rewrite that as something that's going to be easier to solve?
Log of 2.
No.
Log base 2.
No.
32. What?
No, I'm not going to take the log of both sides. Yeah, although I could. My strategy right now is to use one of these 4 properties.
Oh, okay. 32 equals 2 to the power of 5.
So it might be wrong, but I think it's
2. Well, that's true. So as an aside, we could do 2, 4, 8, 16, 32, 64. How far do we need? Oh, just 32.
alright.
2 to the x, that's 2 to the 1, 2 squared, 2 to the cubed, 2 to the 4th, 2 to the 5th. So that's true. 32 equals 2 to the 5. But my rewritten equation right now should be just doing one step. All I need to fix is one step. What's my one step that I want to do?
2 to the 5.
Maybe you want to convert the 32 to the
Yeah.
base.
So I'm going to rewrite 2 to the x equals 2 to the, what did we say? 5th?
Yep.
That's what I said.
You said 32 equals 2 to the 5th.
Sir?
Which is true.
That's not our rewritten equation. That's this step.
That's the solution.
Yes, so this part is right. So converting 32 to 2 to the 5th is the correct step, but we want to rewrite our solution. Now what's the solution?
X equals 5.
X equals 5 for what reason?
1.
One-to-one property.
1, 2,
You could just say
1.
it's true.
Can we just do the number 1 and then 2 and then the number 1?
Yeah,
It's
if we
like-
like.
Not the number 1, the number 2, the number 1. No, but you
No,
could
I'm
do
saying- I'm saying like
1, 2. Oops,
No,
I did it.
one,
I just
and
did
then
it.
T-O.
1 to 1.
Yeah, that's what I'm.
Yes, if you're wanting to write your, and on these homeworks, you are going to be writing your reasoning. So yes, you will. You can say that's perfectly. Either version of this is perfectly readable and acceptable.
Okay, because 1 to 1 might be a lot to remember.
Yeah.
It
So
just
it's a
takes
1 to
up-
1.
It takes up a lot of space.
1-to-1 property. I encourage you to find a red pen, because as you're doing your work, it makes it easier to realize that this is not a math step. This is a justification. It's a different thing. So when you're doing your 2-column format on on solvings, yes, you can. A different colored pen out to the side is highly recommended.
I'll do a blue pen.
I
Yeah.
have
This
a
is
pen.
to the second.
Okay, all right, go Miles.
Is it e to the x over 3 equals 0? Or log natural of x over 3 equals 0?
No.
Either of those
No.
we're looking for.
You could do that. You could do that. It's not an illegal step or anything. But what I'm wanting to do is I'm wanting to find one of these 4 properties to make it. I want to make my original problem look like one of these 4 properties.
So, log natural of x minus log natural of 3, if log b of x
Mm-mm.
equals,
Plus.
Well-
It started off subtracted and equals
So-
0.
if x is 3,
Go ahead, CC.
then they subtract.
Natural log of x plus 0 equals natural log 3.
Can't you just
Kind of.
Can't you just do log natural of x equals log natural of 3?
Yes.
That's what I said.
You said plus 0.
Oh, but you have to plus 0 in order to have
Why do
that.
you need a
Okay.
plus 0?
Because you need
0
to
is
move.
nothing.
You can't
Which
move
is
it.
zero.
Okay, if you wanted
You
to
can't
do it
plus or minus
each
zero.
step, if you wanted to do each step, then yes, you would keep the 0.
You would
but
minus, you would subtract, and you would.
I never worry about the
add-
0 actually.
Add natural log.
I never worry about the 0. I'm just adding log. I'm adding natural log of 3 to each side.
Don't you just use 0 as like in this case?
It's just 0.
It's
So
just like the 3's
I'm adding ln3 to both sides. ln minus ln3 plus ln3, that is 0. And then 0 plus ln3, that is ln3. So what's the solution?
X
X
equals
equals 3.
From what property?
1 to
1 to 1.
Can I write that in a black pen?
That's what.
Huh?
Can I write it in a black pen?
And your rest of your work is in pencil?
Yes.
Yeah. I'm recommending that you have this stand out.
It's just like a standout color.
Its standout color makes it easy for me to read.
Yeah.
It makes it easy for you to remember to put your justification for each line.
Let's see right.
How does square block work?
Donovan, can you start us on number 3?
Yes. You can do. There's no. It's like that. Can you do?
Wait. Why is x is equal to 5?
Can you do?
Oh, thank you.
Can you do 3x equals 9?
Say it again.
3x equals 9. Or
No.
wait.
3x?
No, never mind. This is.
What did you need 2? You would need like, this is like a 2-step.
It is 2 steps. What's the step you want to do on the left?
So you would do 3 negative 1, right? I'm pretty sure. I think you do it. 3 negative x, not all.
Well, in 2 steps you could do it as 3 to the negative 1. So 1 over 3 can be rewritten as 3 to the negative 1 to the x. These things get multiplied.
Oh, so that's 3 to the negative x
Yeah.
equals 9.
So it's 3 to the negative x, but 9 is not at not to the same base.
9
It's
equals
not.
3 squared.
So you would do
3 squared.
So you'd have
So
to add
what's my answer?
3 steps.
X is equal to negative 2.
Yeah, x equals 9.
X equals minus 2, and what's my property?
Oh wait.
No, yeah, 1, 2,
1, 2, 1. Do you notice that this is actually a faster way to solve these? So what I'm doing is I'm solving it left to right, and I'm only giving one justification at the end, the name of the log property. Miles, why is your computer open?
So there's less work to show.
There's less stuff to show, so I'm only showing one line. Yep. Jordan, can you help me out with D?
Number D.
Number 4?
Yes.
Sorry, it's
It's
D
late
over
on a
here.
Tuesday.
It's D over here. Sorry.
It's late on a Tuesday.
And some of us have 5
It's
classes
only
today.
Tuesday.
It's already Tuesday. Think about it like
Okay, everyone should be looking at this one because number 4,
It's weird.
or number D, is a little bit different. It's very slightly harder than the ones that we've done before. Why? What's different?
You have to rewrite it as log natural.
Oh, you have to, because
Oh,
it's.
could you
Okay,
log
it's
natural
natural.
both sides?
Natural,
natural
natural.
E
of
equals
x
E
equals log
Yeah.
natural of 7, so
That's
x
true.
equals
You could
7
do that.
You
by
have to,
1 to 1
Yeah, yeah,
property.
yeah, yeah.
No, that's
No,
not
no,
how it
no,
works.
no,
That's
that's
not
not
how
working.
that
You
doesn't
have to
work.
eat it.
Doesn't work
It
yet.
would,
You
would
have
do
to-
you would have
you
log,
have
so
to-
it would be 7. I mean, it would be x equals
So
log
x
natural
equals
7.
7.
No, it's
No.
not.
Okay,
No, no, no.
so what do I write here for my rewritten equation?
Log natural of x equals log natural of 7.
Where is the
Where
E?
is?
Because
No,
Why does the E
Where's the E?
disappear?
no. I'm gonna take the natural log of both sides.
Yeah, so you
Yeah.
take
Yeah.
the natural log of both sides.
So what do I rewrite?
So you would have x equals.
No, I'm gonna go ahead and write ln of
Of
e to the x
equals
equals
log natural
log-
7.
natural log of 7,
Yeah.
and then I can solve it now. What is it, Max?
So the ln e cancels out, so
Yeah.
x equals ln 7.
X equals ln 7 by what property?
Oh, is that simplified?
That's simplified.
Okay.
So this is what I was saying. Is this one's very slightly harder because 7 is not a number that I can express as e to some base. I mean, sorry, base e to some exponent. Just doesn't work that way. It's e to the ln 7.
This is inverse property.
Yeah, inverse. Cece, can you help with number 5?
Sure. What are you solving here?
Oh, ln x.
That was a good question.
Yeah, so
Oh yeah, that's a good. Yeah, I didn't know that.
Log equals no. It always has to be log of something.
Um, so, e to the power of -3 equals x.
I want to do a little bit more systematically than that. I want to do one step at a time.
Well, before you didn't do one step at a time.
Yes, I didn't.
no, you did.
Yeah, I mean, he didn't. He showed it, but he just erased that. But yeah, he did show it. I mean, for number 3, that was different because we had to do like 10 steps. But yeah.
But it is what
Five.
it is.
Yeah.
So, well, you just converted it into like exponent.
What?
The ln x equals
Okay, so what do I write?
e to the power of -3 equals x.
No.
E to
E to
ln
the ln x
E to the ln x
equals
equals -3 to the ln.
no. What am I doing to both sides here?
Never mind. It's
What am I doing to both sides?
It's plus e.
So you would also do to give it.
What's this called? What's this step called?
E.
E.
Oh, wait,
E e to the power.
I'm
E to
exponentiating.
the power of negative 3.
E to the power of negative 3.
Right.
Yeah.
And what's the answer?
It's a good
CZ?
question.
What?
What's the answer?
Oh. What?
What's the answer? What's the solution?
Negative, what?
What's the answer? How do I solve this? What do I do? What do I do with this step?
E to the negative.
What do I do?
You like go cross out
Yep.
and ln.
Yes.
So x would equal negative 3? No, e to the negative 3.
E to the negative 3. Or if you wrote E 1 over E cubed, that's fine too.
Yeah, that works.
And what property did I use?
Inverse property.
Yeah, if I scratch out anything, it's pretty good chance I'm using inverse property. Lily.
Wouldn't you just do basically the same thing? Or
So what do I? So let's do it.
so 10 to the log x.
Yeah, you chose 10 because what?
Because the base of
Because 10 of log with no base is assumed to be 10.
and then b equals 10 to the negative.
10 to the minus 1. And so what do I do as the next step?
You cross out 10.
Emily, where are you on your laptop? Cross out
Cross out 10 log,
10 to the log.
and it's x equals 10 to the negative 1.
10,
Or 1 over 10 to the just 10.
right.
Oh, you could,
What property did I use?
Inverse.
I used inverse. I know that because I crossed something out. Emily, help me out.
This was the one I was confused on.
Well, let's do the steps.
There it is, the last one.
Let's do the steps.
So,
Oh.
Hmm?
wouldn't it be x to the power of wait, 4 to the power of 3,
No.
x to the power of 3?
So what base did I use here when I exponentiated?
E.
Why?
Because that helps Ellen.
Because
There was ln f.
because ln and natural log has base what?
E.
E.
And here I used what as my base?
10.
Because log, if you don't write it, has a base.
So it'd be log, or 10,
No?
wait, what?
Here I had base E.
Wouldn't you use the
Here I
base?
have base 10.
Wouldn't you use
Here
the
I have base.
Oh, shoot. So 3 to the log x equals 4.
3 to the log base
3.
of x equals.
3.
3.
So usually what I do at this stage, Emily, is I actually write a gigantic 3 here and a gigantic 3 here. That's my way of showing that I'm exponentiating. And then if you write it like as a new line, perhaps, or write it in a normal font, it looks like this. But I'm exponentiating. I'm raising both sides to the 10, or 10 to that. I'm exponentiating e here. So writing down what you're exponentiating, e because that goes with natural log, 10 because that goes with log base 10, 3 because that goes with log base 3. So this exponentiating both sides gives me 3 to the log base 3 of x equals 3 to the 4. That's why writing it this way is helpful. So I don't write. I'm not tempted to just write 4. So what's my answer? What's my solution?
X
Equals.
Is it x equals?
Yeah.
Yes.
Why? What was I supposed to?
Cancel out 3.
What was I supposed to cross out?
3 and log 3.
Log, or just 3.
3 to the log base 3?
So
That leaves
x
x.
equals 2,187.
No, 3 to the 4.
That's
For
81.
2,187.
That's
3 squared times 3 squared.
81.
That's 81.
It's 81.
Now, where'd you get 3,000 from?
But it's 3 to the 4.
It's 3 squared times 3 squared.
Which
Is
is 81.
Which is
81 squared.
No. Where are you getting the extra
Wait a
square?
second. Never mind.
9 times
81 squared?
9 times 9.
Miles.
3 times 3 is
That
9,
was
Miles.
six.
Yeah, I was getting the, I was multiplying it again for some reason.
What?
What?
How did you even
Explain.
So that it was like 81 times 81. I was
Oh.
doing 3 squared
Oh,
4 times.
man.
So you were doing 3 to like the 8th or something.
Yeah.
Miles.
What property did I use, Emily?
Mm, 1 to 1.
Where 1 to 1. 1 to 1 takes the similar things out of the exponent or the similar things out of the log.
Inverse.
Inverse is when I scratch something out.
You did scratch something.
Yeah,
Yeah.
so it's inverse.
Yeah.
What?
That's what you didn't say.
You said 1 to 1, I thought.
No.
She did.
Yeah, you said 1 to 1.
He's gaslighting. She's trying to gaslight her way out of it.
Sorry. I said 1 to 1 first, and then I said inverse.
All right, you try these.
No.
No.
That excuse
No.
is the problem. Do you know they're not that
You
bad?
should,
No.
you should give us some from the homework. And then if we have
What?
questions, we can ask you. You know?
No, yeah, since we can't really do that anymore. Look at that. Those unfair
They already got
loser
out
algebra.
Just
Come on.
out there laughing and having a good time.
They're probably gonna go
Loser
get
algebra
food.
two.
How
Hours.
dare they.
Says it's time to stand.
It's field trip to the arcade.
I think
That
we,
Ed,
Mr. Shira,
honestly,
we should get
I
like
love
a
it.
1 minute stand.
Are you done? Did you do it?
But no.
Eventually.
Honestly, I love the new arcade. Honestly, so.
I just wish it was student. You know.
I wish
I
it
mean,
was
I'm not sure how they would
That's
cook
a good
it though.
point.
You know what I mean? Who's cooking? You
But if only it was like less than $6 for a drink. You know?
Yeah.
know? It's nice though, but
We'll
it's
put 3,
cheaper
that'll
than
be way
this.
more.
Nice. I don't know how those prices are killer.
But I mean, I guess it keeps people from making everything out of stock.
Avi,
Yes.
what do you think?
For A,
Yeah.
to the 2 to the x is equal to 2 to the 9.
That might be.
No, I thought it was.
No, that,
No.
no, it's
Oh,
definitely,
no,
it's
it's
definitely.
2 to the 10 is 1054.
Right, she's right.
I mean 1024.
Yeah, she's
So yeah,
right.
2 to the 9 is going to be half of that. So what's the answer?
X is equal to
X equals 9 by what property?
9. I don't know.
1, 2, 1.
Oh yeah, X definitely equals that.
If you didn't know that, how would you find what your exponent's supposed to be?
Count it on your fingers.
You know, honestly,
Nailed it.
More or
2 to
less.
the 1 is
you
2,
could
and
I
then
have
it
never
goes
seen you
4,
roll your
8,
eyes so
16,
dramatically.
32, 64, 128, 256, 512 is 9.
you could do it.
You could do it that way. If you don't do it that way, what's the other option?
Chart.
Make a chart.
Give it a try, yeah.
All right,
Sorry,
Miles.
Fingers are better.
So you
It's like a
write
4.
6 to the log 6 of x.
Yeah, so I'm gonna put a big
6
6
to the
here.
3.
You
I'm
killed
gonna
it,
put a
Miles.
giant 6 down here.
And by so that's inverse property, and then you cross out the 6 in the log 6 to get x equals 6 to the 3, which I think is 216. Probably.
Donovan,
Yeah.
can you help me with C?
Yeah, I can attempt to.
Yeah, I think that.
You first want to move 5 to the other side, right?
Yep.
Is that your first step?
Mm-hmm.
Okay. So negative negative e to the power of x equals negative 5. Right?
Where's South Pair?
Well, right.
Like that?
Yep. And then you need to get rid of e. Let's get rid of e. You put you do ln to the ln 5 equals ln e to the x.
Right. What property did we use?
Inverse.
Inverse. And Jordan?
Okay, so for E, we line X, so. You could, so, so first, you flip the 1/3 to get 3 to the -1. And then, okay, so then you would then change,
This is like your lab.
Would you do 3 to the
I mean,
square?
I mean, you do,
So look, you can just you can isolate the part that you're trying to look at, so you don't have to worry about everything all at the same time. What's the way to rewrite 9?
3 to square.
3 squared to the x equals 3 to the minus 1. So how do I get rid of the parentheses?
You do 2 times x.
Yep.
So 3 to the power 2x.
Oh, that's 2 to the x.
And then
These two-
cancel them,
Yes.
yeah.
This is a power raised to a power. That's multiplication.
And then that's
So this actually now I'm ready to rewrite my rewritten equation is in here. That took more steps, so I did it off to the side.
and then 2x. Where x equals negative 1 half.
And what property did we use?
That's definitely 1 to 1.
That's 1 to 1.
So 2x. Okay, so x is 1.
Okay, so those were the easy ones.
Whoa, what's that?
Those are the easy ones.
Is that what 5.4a will look like? Mostly, or no?
I don't know.
But
All right, let's solve this. Max, what do you think?
You remove the e's. So negative x squared equals
So I'm going to write original equation, and then I'm going to write what?
oh, that's the so negative x squared equals negative 3x minus 4.
And using what property?
1 to 1. Then you move the right side to the left, the left side to the right, so you get, I'd move it to the right, so x squared minus 3x minus 4
What?
equals 0.
I did a couple of steps there. It might have been easier to write it on the right because you're just adding x squared to both sides.
And then you use the
Is that better, CC?
Yes.
use the quadratic formula to find x.
This is right in general form.
I see, yeah. Makes sense. That's making sense.
What's general form again?
It's the. Is it the bx one? Right? No, that's different.
X squared equals bx plus c.
What's general form? What makes this general form?
ax plus bx
AX.
plus c.
Ax squared
Oh,
plus bx plus
Plus
c.
c.
Oh, yeah.
Right. So I'm writing it in decreasing powers of x.
Yep.
That's general form. So yes, quadratic, or you could factor.
Yes, factor.
Why do we have to go back to factor?
You know, we can do
Because factoring is faster. Factoring is easier. What do I need? What do I need my pluses and minuses to be?
So, 1 to be minus 1 to be plus.
1 to be minus and 1 to be plus.
X minus 4, X plus 1.
X minus 4 plus 1 gives me minus 3. Multiplied together to give minus 4. So that gives me X equals
negative 1 and 4.
-1 and 4.
X equals.
And then the final thing we did.
Right.
Hi, Charles.
Hi, Charles.
How you doing?
Okay, you do this. You do this one on your own. Charles, how do I do that one?
Where? B?
Yeah.
Learning about logarithms?
In exponents. Solving exponential and logarithmic equations. How do I do it? How do I do it?
We need to go
How?
to the next class.
How? Tell me.
X equals
need
log
to-
14 over log 2.
What?
Imagine.
Wait. Yeah. Wait, what?
What's 42 divided by 3? 14.
Yep.
And then
4. Wait.
How do you get a
Yeah, how'd you get
Oh,
4?
because
Yeah,
you
yeah,
divide.
yeah,
No,
yeah.
no, that's that's fair.
I'm cooking.
Takes
Yeah.
a lot of base to up.
Yeah, 2 7.
X equals 4. Alright, great, I'm done. Bye.
Boom.
and then how do I change the base? Change the base. Change the base.
It's 4. Why did it just change it?
Log base 2 of 14 is not 4.
Well, the X. You just initial.
What's change of base?
Change your base.
What's change of base?
14 over 2. 7.
ln
It's X.
14 over ln 2. All right,
Thank
we're
you,
done.
Mr. Shano.
Thank you.
Thank you, Mr. Sheriff.
See ya.
That's what I said!
That is
What?
what you said.
You said log 4.
I said
You
14!
said 14 over 2.
I said log 14 over log 2.